So this project is related to urban traffic flow optimization using the PDE partial differential equation. Constrain the optimal control Greenshields based LWR traffic modeling approach in MATLAB. So LWR basically Lighthill-Whitham-Richards, basically one of the scientists who just developed the traffic modeling approach for the Greenshields based. Okay. So in this article, I have just write the abstract like how the operational research of the control is computed using the gradient-free nonlinear programming via the under physical and safety constraints. So the numerical basically simulations validate the model by analyzing the density, valuation, optimized inflow rates, and the convergence of the cost function as well. So the next one is the introduction. Introduction basically contains the urban traffic congestion is one of the main optimization flow, and the main challenge is that we need to control the mathematical modeling versus and the optimal control techniques that are increasingly utilized to understand and regulate the large scale traffic dynamics. So this one is related to, yes, next one is basically this work basically demonstrate a complete pipeline from the mathematical modeling to simulation control implementation and the results visualization to provide an effective and computational efficient method for urban traffic management. So here is a background and need for optimization. It means that we need to optimal control techniques, and we need to use optimal control techniques which enables a systematic analysis of flow breakdown and the congestion propagation, yet and without regulation. High density zones naturally emerge around the bottlenecks, reducing the throughput and increasing delays. Okay. Role of PDE models basically it defines that how the final density versus desired density and how we can adjust the urban traffic flow optimization using the PDE constraint control models as well. So here is the optimal control of RMAP metering basically, which is quadratic cost functional is constructed to the penalize the both density mismatch and the control magnitude. So the resulting optimization problem becomes a PDE constraint control problem solved through the numerical solutions simulation within an iterative optimization loop. So the problem statement is here, and the mathematical model. Mathematical model basically provide us how LWR means Lighthill-Whitham-Richards. Okay, is a scientist who proposed the law of traffic dynamics, which is the governing equations are there, and in the linking of density to speed, reducing the higher flow of levels. Okay. So here is basically the optimal control problem seeks to minimize the cost functional. And next one is the methodology. Methodology basically contains how mathematical models, conservation law, flux, control term, cost, and basically the next one is how we can use a finite volume method computes the density valuation using the Lex Frederick's fluxes and robust against the nonlinearities. So here is a MATLAB design simulations and its analysis. First of all, I have just defined all the parameters used in the MATLAB simulation in terms of road length, total time, time steps, in terms of speed, and in terms of special cells, its weight, maximum ramp input, ramp locations, and also we have defined how the traffic PD numerical solved through using a finite volume Lex Frederick's flux scheme. Okay, and basically in our MATLAB overall simulation demonstrates the effectiveness of PDE based optimal control for real-time urban traffic management congestion suppression. So here is the MATLAB simulation output results according to the density versus desired density. Okay, desired density mean this density is shows the blue line is the final density, and desired density is basically dotted orange line. Okay, density evaluation as well as the output graph of optimized ramp and metering control. Next one is basically cost history. This is a cost history according to the eval, and convergence history and density snapshots according to different time scales. And yes, basically each curve highlights the stabilization of traffic flow dynamics, and basically profiles remain within the physical density bounds. And discussion results of discussion versus, and the density snapshot basically demonstrates the excellent tracking of the target profile at late simulation times. And next one, I have added the conclusion versus references. Okay, so let me show you the MATLAB demonstration of the code, which is basically, yes, urban traffic. Yes, it is already open. So you just need to run this urban traffic flow optimization using a PDE-constrained control LWR model. Okay. Here is the optimization starting, and it will take some iteration counts. When the iteration completed, then it will show us the output results accordingly. See, these are the MATLAB output results, final density versus desired density. Here is the density evaluation. Here is the optimization RAM, optimized RAM metering control, cost history, as well as the density snapshots. Okay, so I think it's done. If you need to ask anything, you just ask me. I will answer your questions. Thank you.